Okay, let's go ahead and get started. Okay, so a couple of things we've got coming up. Our next exam is next Wednesday, a week from today. Okay, so in the module, okay, we'll go to module 7, I think. No, module 5. No, module 6. Okay, so this is us this week. We're in module 6, week 6. Okay, and so if you need the notes are here. Okay, we're going to cover the remaining of 7.6 and 7.7 today. Okay, here's a finance flow chart that you might want to take a look at. Okay, one deposit, many deposits, many withdrawals, many payments. Okay, here's annuity. Okay, one-time interest, interest over time, simple interest, compounded interest, and here's all the formulas that you would need. You don't need to worry about the annuity, but you do need to know about simple interest and a loan here, the loan at the bottom. Okay. Another thing to take note of, okay, so on the 11th, where's the exam not here? The exam should be here. So let me put the exam in. Okay, so on the 7th, we have an exam, we have our exam 2. This will open up on the 7th, okay, for week 7. Okay, the 7th of week 7. Okay, in module 7. It's all set, coming up 7s. Okay, so October 7th, next Wednesday. Okay, you do not need to log in to class next Wednesday. Okay, you merely need to take the exam. So you just take the exam here at 2 o'clock. It'll open up for you. Say exam 2. Okay, and it says, hi, here we go. And it's due at 3:40. Okay, there's 20 questions. Okay, and then you'll then upload your work here. You'll take a picture of it, upload your work. Where'd my module go? Okay, and then you'll just upload your work here. If the upload doesn't work for you, you can always email it to me through Canvas as well. Okay, but it should upload. Okay, this isn't 1 point. This is 100 points. Should be 100. I don't know why it didn't save. Oh, let's be because I didn't update it. Let me do that right now. $100 points. Update question. There we go. Save. Boom. There we go. Now it's 100 points. Okay, so, and then you're just going to upload. Okay. It says please upload all work for exam. Let's just say exam 2. Messing up all over the place. Okay, exam 2. Please upload all the work for all problems and not just the work for the first problem. Okay, so just very similar. Again, a week from today, you do not need to log into class. You merely need to take the exam. If you have issues, you can email me and I'll log on remotely to help you out with any of your issues. But you do not need to be in class next Wednesday for the exam. Okay, it will still be during the exam time though, from 2 to 3:40. So keep that in mind. What else? Your work is due by 4 o'clock. So the due date is 4 o'clock. Okay, I am concerned about the low exam scores last time. So make sure that you're doing the exam review. Let me cover that as well. Okay, so let's go back to the module. Okay, module 7. Okay, make sure that you are doing the exam review. So next week it'll say exam review. Where is my exam review? Exam 2 review. Let's add that right now as well. Okay. Okay, and that's due October 7th as well. Okay, I want to put this down here. Okay, and then you also have your personal finance project, which is due 4 days later, Sunday night. So it says download the cover sheet. Okay, with all directions. So this has all the directions that you need to do your project. Okay, step 1, choose one of the 3 scenarios: buy a car, buy a house, finance college. Okay, here's the sources that you're going to do, and you're going to go through steps, okay, 1 through 12 here. Okay, if you want to use an equation editor, here's how you use an equation editor in Microsoft Word. Okay, there's also an example of someone who got full credit on this. I don't know why it always does that. Okay, so here's an example of someone who got full credit on this last time. Okay, so this is an example. Okay, and this is what they did. They filled out, okay, all of this, used the correct formula, calculated their payment. Okay, this is how much payment they would be paying out. Okay, the one that I used in class was, you know, financing a car. Okay, so they use that one as well here. They want to find the monthly payments for a 2018 Nissan Altima. Okay, to be over 48 months. Okay, without a down payment. No down payment was made here. Okay, so they don't. Okay, then they said, well, what happens if I put 10% down? And then, you know, I would have to subtract off 10% of the purchase price, and they calculated out the payment as well. Okay, so you're basically just going to answer all 12 questions. Okay, you can type it out as such. Okay, in Word or Google Docs. Okay, and they even got five points extra credit here. So it's going to be out of 100, not out of 50. This was when it was out of 50, but I'm going to make it out of 100. Okay, so there's 10 points worth of extra credit up for grabs as well. Okay. Stop the sharing. Yeah, that's the project, exactly. So you just go through, answer all 12 questions, given the scenario and the research. You're going to research either buying a car, buying a house, or financing your student loans. Okay, so either way, you're borrowing money, and you're just calculating the payments and how much it's going to cost to make those payments, give it a certain amount down. Okay. Okay, so that's the personal, that project is going to be due in, what is it, like 10 days? No, 12 days, something like that. Okay, so you have plenty of time to work on it as well. The project is individual, yes. This one is. The next one I may do group for the second one. We will do a second one on statistics, which I will make that I might make that a group project, but this one is individual. Okay. Now, does that mean you can't work with somebody on it? Sure. I mean, if one person chooses one type of car and the other person chooses a different type of car, then you guys are going to have different calculations, but you can certainly, go through and say, oh, okay, did you do, question 8 correctly here? And they're like, well, what did you get? Well, this is what I got. So again, you're going to have different numbers, same format though. Any other questions so far on this? Okay, so that's just what's due. Again, I'm a little concerned about the low grades in the class right now from some of the students. That doesn't mean that you're not doing the work. You are doing the work. It's just again, we want to get those exam grades up. So let's make sure that you are working on the review. So let's go back to the review real quick. Okay, make sure you work through the review. And what I would do is I would actually not just, I would get a notebook and I would just copy down how to do each of these problems. Okay, well, how did I do number 1? Boom. How did I do number 2? Boom. How did I do number 3? Boom. Okay, there's 39 practice problems for you to work on. Now, is that going to take time? Yeah. But, it's basically how well do you want to do in this class, right? It takes time to learn stuff, especially math. It'd be like throwing someone into an Olympic-sized swimming pool and say, okay, go ahead and do 40 laps in this Olympic-sized swimming pool. You'd be like, well, you're crazy. I can't do that by just throwing in. You're like, it takes time for me to train for that. I'm like, well, yeah, exactly. And if you train for a few months, then if I threw you in an Olympic-sized swimming pool, you'd be like, okay, well, maybe I could do 20 of these laps, without dying. So, okay. Otherwise, people just end up drowning, right? It's like, I can't do this, and then that's how they start to drown. They don't put in the time. Okay. Again, you can sit here and watch me do everything on YouTube all day long, but you can't do. I can't train you on how to do something if you're not willing to pick up the pencil yourself. So there's a big difference between teaching and learning. So learning is active. Teaching is passive. It's the same thing that I taught my dog how to smile. I taught my dog how to smile. The problem is he didn't learn. He didn't try to smile. I could teach him all I want. But he's not going to do it unless he tries. Right? So anyway. Okay. Let's go back to next week. Talk a lot about next week. Module 7. Okay, so exam 2 review. Again, make sure that you work through these. Okay, problems. Okay. It says 190 points possible. It really isn't. Okay. Okay, so here's all the questions. Okay. And for you to work through. There's 38 of them. Okay. So the assignment itself, it's only 19 points. Okay, so it's not 190. It's 1/10 that. Okay. Anyway, make sure that you're staying up on your work. I guess that's all I'm trying to say. Okay, let's go over attendance now, real quick. Okay, Cassidy?
Here.
Alejandro?
Here.
Liliana? Lainey?
Here.
Cassandra?
Here.
Cassandra's here? Okay. Romeo?
Here.
Viviana? Brenda?
Here.
Jasmine?
Here.
Josue?
Here.
Jade?
Here.
Okay, Valerie? Edsel,
Here.
Joel,
Here.
or Joel, Monique,
Here.
okay. Salvador,
Here.
Caitlin,
Here.
Kayla,
Here.
Romeo Ramos,
Here.
Paula,
Here.
Aaliyah, Ricardo,
Here.
and Matthias. Okay, sounds good. Okay, so one last time. No Liliana, no Viviana, no Valerie, no Aaliyah, and no Matthias. Okay, perfect. Oh, Valerie's here? Valerie Gonzalez. Oh, okay, gotcha. Okay. Okay, let's finish up chapter 7 in our notes. Okay. Und this. There we go. Oh, Liliana's here? Leah, Viviana, and Matthias. Okay, sounds good. I think I'm gonna have to drop those guys. Okay. Emily bought a car, $24,000 for $24,000 3 years ago. The loan had a 5-year term at 3% annual interest. How much does he still owe on the car? Okay, how much does he still owe on the car? Okay, so let's look at our handy dandy formula here. Okay, the present value is equal to the deposits times 1 minus, okay, 1 plus r over n to the negative nt, okay, all over r over n, right? Okay, I think that's the right formula. Okay, so first thing we need to do is calculate the payment. Okay, so we don't know what the payments are on this on his original loan. So I need to calculate that. Okay, so I know that it was for 24,000. Okay, D, 1 minus 1 plus, this is 3%, so that's 0.03 over 12, okay, because we're assuming that a car loan is 12 monthly payments in a year, raised to the negative 12 times 5, okay, all over, that's an R, 0.03 over 12. Okay. So if I take 0.03 and divide by 12, oops, 0.03 and divide by 12, I get 0.0025. Okay. So this is 24,000 is equal to D times 1 minus 1.0025 to the negative 60th power, all over 0.0025. So now I just need to do some algebra here. Okay, so I'm going to multiply both sides by 0.0025. Okay, and I end up with a 60. If I multiply these two together, I'm going to multiply that times 24,000. I believe that's 60. Yep. Okay, so this is 60 is equal to, cancel that out, d times 1 minus 1.005 to the negative 60th power. Now, how am I going to solve for d? Well, I divide by 1 minus 1.0025 to the negative 60th power. Okay, all over 1 minus 1.0025 to the negative 60th power. I can divide by that. And I can say that d is equal to, okay, this thing, 60 divided by 1 minus 1.0025 to the negative 60th power. So let's go ahead and do that. So this is 60 divided by, you have to put parentheses, 1 minus 1.0025 raised to the negative 60th power, close parentheses, hit equals, and I get about $531.25 per payment. I'm sorry, $431.25. 431.25 is the amount that I'm paying every month. Okay. So now I just need to find out, well, how long, or how, what does it ask me for? It says, how much does he still owe on the car after 3 years, right? After 3 years. Well, if it's been 3 years already, then there should only be 2 years left on the loan. So 2 years left on the loan. Okay, so after 3 years, we have 2 years left on the loan, right? Because it was a 5-year loan. So we want to know, well, what's the present value of this loan? How much is owed still on the car? If I made one lump payment to pay this car off today, say I inherited some money or something, and I want to pay off my car today, how much would I have to pay off the principal? We don't care about the interest. We just want to know how much is the principal left on this car. So we're going to do our 431.25 times, okay, 1 minus 1.0025 to the negative 24th power. Now, why 24th power? All over 0.0025. Where did the 24th power come from?
24,000.
No.
Those are the remaining 2 years.
Yeah, that's the number of payments that I would have remaining. Okay. Yeah, it's 2 years times 12, which is 24 months. Okay, so the present value on this, okay, let's plug this into our calculator. Okay, is going to be 431.25 times 1 minus 1.0025 raised to, this time, the negative 24th power. I'll close my parentheses, and then I'm going to divide by 0.0025. And it comes out to about $10,033.45. So after 3 years, I still owe $10,033. And 45 cents on the car. So this is how much is owed after 3 years. Okay. So I've paid a lot of interest, and I've paid about a little over half the principal, okay, in that 3-year period. Okay. Okay, let's do another one here. Okay, a friend bought a house 15 years ago.
Professor, sorry to interrupt. What was the calculator that we could use to do this?
Well, you can use any calculator. The one I'm using is the one on Windows 10. So, but if you have a Mac or if you have a Chromebook or something else, you can just Google any scientific calculator.
All right, thank you.
Okay. A friend bought a house 15 years ago, taking out a $120,000 mortgage at 6% annual interest rate for 30 years. How much does she still owe on the mortgage? Okay, after 15 years, halfway in. We want to find out, okay, halfway in, how much is still owed? So again, we've got to calculate the payment, okay, and then use that payment information to calculate how much is left over. Okay, we'll deal with the follow-up a little bit later, but again, very similar to the one that we just did. So P equals D times 1 minus 1 plus R over N, plus R over N to the NT power, negative NT power, all over R over N, right? Okay. So we're solving for D again this time. Okay, so the total purchase price of the home is $120,000. That's going to give me the that's going to allow me to find the payment information. Okay, what will the monthly payment be? So this is 1 minus 1 plus, and this is 6% this time, so 0.06 over 12. And then this is going to be over 30 years. So this is negative 12 times 30, all over 0.06 over 12. Okay, so 0.06 over divided by 12, that's 0.005. Okay, so I'm going to multiply both sides by 0.005. And that will give me, what? 0.005 times 120,000. 600, that gives me 600. So 600 is equal to D times 1 minus 1 plus, or I'll just say 1.005, raised to the negative 360th power. So once again, divide by 1 minus 1.005 to the negative 360th power. Okay. And this will give me my payment information, D. Okay, so 600 divided by parentheses. Don't forget the parentheses, because it's everything on the bottom that we have to divide by. Okay, parentheses 1 minus 1.005 raised to the negative 360th power. Okay, close parentheses, equals, and that's $719.46. That's the amount of payment over a 30-year period. So this is the payment amount over 30 years. Okay. So I want to know, well, how much is left on the house after 15 years? So that would really just be at the same payment. I would want to finance this for 15 years instead of 30. So I would cut this 360 in half. Okay, so I'd say, oh, what's the principal? How much house can I afford if I make the same payment? Okay, but I do that over 15 years instead of 30. Okay, so it would look like that. Okay, so plug that into a calculator. So 719.46 times 1 minus 1.005 raised to the negative 1/80th power, so that's 15 years of payments. Okay, divided by 0.005, and it's 85,000. Okay, 85,258.54. So that's the amount of house that you could buy if you wanted to make the same payment, but do it over a 15-year period. This is 15 years of payments.
Professor, quick question. I just missed that part, but the part that I missed was, where did you get the number 0.005?
Yeah, that's 12 divided by, or sorry, 0.06 divided by 12.
Oh, okay.
R over N.
I have a question, Professor. So for the 1 minus and then the parentheses 1 plus point and R over N,
Right.
can we just leave the 0.005, or do we need to have the 1 minus 1.005?
Okay, you need to have the 1 minus 1.005. So I can put it like that if you really want. Okay, because it's 1 minus something to an exponent, and you have to evaluate the exponent before you subtract. Okay, because that's order of operations. So if I did 1 minus 2 to the 5th power, well, which one would I have to do first? Would I do a 1 minus 2? No, I would do 2 to the 5th power and then subtract 1. And I would get negative 31. Does that make sense?
Yeah.
Sounds good. Okay, so the follow-up to this was what? Follow-up was, how much has your friend paid of the loan? How much has your friend paid of the loan? Compare this to your friend's total payments. Okay, so how much has he paid off the loan? Okay, so 120,000 minus 85,258.54 is equal to 34,741.46. This is the amount that's been paid off. It's not a lot over 15 years, paid off in 15 years. Okay, and then what else did it ask me? It said, how much has your friend paid off the loan? How much has your friend paid of the loan? Compare this to your friend's total payments. And how much were the total payments? Well, they would have paid $719.46, and they would have made that 180 times. What's this? 719.46 times 180 is 129,000. Well, they would have paid $129,000 so far just in payments. 502.8, and then that's the total payments that they would have made, whereas they only paid off. This is the total payment in 15 years, whereas they would have only paid off this much in principal. This is the interest. Or sorry, not that's the principal. No. Yeah, that's the principal that they would have paid off. Okay, and this is the total payment, so I could actually find the interest by subtracting these two amounts. So 129,502.8 minus 34,741.46. Okay, what is that? That's equal to 94,761.34. So almost $100,000 in interest in the first 15 years. Okay, so yeah. So the moral of that story is if you're going to buy a house, stay in it a long time. Okay, because if you move, keep moving, you're only paying interest for the first like 15 years. And then after 15 years, you start paying off all the principal. So yeah, again, that's how the banks keep getting richer and richer. Everybody else keeps getting poorer and poorer. Okay, solving for time, 7.7, solving for time. How can we solve for time in this case? Okay, well, let's look at an example here. Joel is considering putting a $1,000 laptop purchase on his credit card, which has an interest rate of 12% compounded monthly. How long will it take him to pay off the purchase if he makes payments of $30 a month? So let's look at our formula here for loans, okay, because it's a loan. He's loaning himself money, okay, so D times 1 minus 1 plus R over N to the N negative NT all over R over N. Okay, so there's our loan formula. Okay, so we want to solve for T this time. So okay, let's see what we can do here. So P 1,000 is the amount that is my purchase price. $30 a month, okay, times 1 minus 1 plus 12% over 12 to the negative 12t power, all over 0.12 over 12. Okay, so again, I want to solve for t. Everything else is pretty much good except for this t value here. So how can I do that? Well, the bottom here is 0.01, so I'm going to multiply by 0.01 to get rid of that guy. 0.01. 1,000 times 0.01, I believe, is 10. So that goes to 10. And we get 30. Okay, so is over here. I could divide by 30. And so I get 1/3, okay, is equal to just what's in the parentheses here. So equals 1 minus 1.01 to the negative 12t. Okay, so we're getting a little closer here. Okay, and so this is going to be 1/3 is equal to 1 minus 1.001, or sorry, 1.01 to the negative 12t. Okay. So I'm going to subtract 1, and then that's going to give me negative 2/3 is equal to negative 1.01 to the negative 12t. I can multiply through by a negative, okay, and that gives me 2/3, okay, is equal to 1.01 to the 12t. I'm going to go over here, give myself more room. Okay, so negative 2/3, or sorry, 2/3 is equal to 1.01 to the 12t. Okay. So now what do we do? Well, we have to use something called a logarithm. And what we do is we take the log of both sides. Okay. So it's a 3. Okay, and so I take the natural log of 2/3 is equal to the natural log of 1.01 12t. So we'll just ln both sides. And what that allows me to do is it allows me to put the 12t in front. So I get ln 2/3 is equal to 12t times ln 1.01. And now what I can do is I can divide by 12 ln 1.01. And so t is equal to the natural log of 2/3 over 12 times the natural log of 1.01. Okay, so we're going to plug that into a calculator. Move that over. Okay, and I'm going to do the top, which is the I got to do 2/3, 2 divided by 3. Okay, and then I'm going to do the natural log of that. Okay, 2/3. I'm going to divide that by the bottom here, parentheses. Okay, parentheses top, parentheses bottom. The fraction is implied parentheses. There's implied parentheses here. Parentheses top, parentheses bottom. Make sure that you know that. Okay, divided by 12 times 1.01 natural log, close parentheses, actually, sorry. Yeah, that's right, and hit equals. And, okay, why is it coming out negative? Oh, that's because I dropped the negative. That's why. There's a negative here. I don't know why I dropped the negative when I moved it. Negative, 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 negative. It's a negative 12. Okay, so if I do that again, let's clear this. I'm going to go 2 divided by 3 and do the natural log of that. I could do the natural log. Let's do that. Let's do it all at once. So I'm going to go parenthesis 2 divided by 3, close parenthesis. Okay, take the natural log of that and then divide that by parentheses negative 12 times the natural log of 1.01. Okay, close parentheses equals, and that's, yeah, 3.39, okay, or basically 3.4 years. Okay, 3.4 years. Okay, and that's how you solve for time. Okay, you have to use natural log. Let's try the next one here. Okay, Pat deposits $6,000 into an account earning 4% compounded monthly. How long will it take the account to grow? Now this is compounded interest, which is a little easier. Remember, compound interest, that's just my PE to the RT, right? So here I just want to find out, oh, it's compounded monthly, I'm sorry. This is P times 1 plus R over N to the NT. Okay, so it's not the loan. The loan formula is a little bit more complicated. Okay, but this is just compounded monthly. So it says that we want it to grow to 10,000. That's the final value. We want the present value to be 6,000 that I plug in, and I want it to be at 4%, so 0.04 over 12. So that's going to be 12, and I want to solve for time again. So 12t. Okay, so let's simplify what we can, and then deal with what we can't. So divide by 6,000, divide by 6,000. Okay, and this is going to be, if I reduce this, This becomes 5 over 3. So this is 5/3 is equal to 1 plus 0.04 over 12. Okay, so 1 plus 0.04 over 12. I don't think that's going to go in nicely. So I'm just going to leave it like that to the 12t. So now what do I need to do? Well, I need to take the natural log of both sides. And that's going to allow me to bring this 12 and put it in front. It basically turns an exponential into a linear when I do that. So natural log of 5/3 equals 12t times the natural log of 1 plus 0.04 over 12. Okay. And then what am I going to do? Well, I'm going to divide by the 12. And I'm going to divide by the natural log of 1 plus 0.04 over 12. There we go. Boom, boom. And so t is going to be equal to, okay, this thing, natural log of 5/3 over 12 times the natural log of 1 plus 0.04 over 12. Okay, so again, just plugging into the calculator is half the battle. Okay, so let's do that. So parentheses 5 divided by 3. Take the natural log, that's going to give me the top. Divide by parentheses the bottom, 12 times parentheses, oops. No. Should be times. Times, okay, 12 times the natural log of 12. No, I don't want natural log of 12. Let's get rid of that. I want the natural log of parentheses 1 plus 0.04 divided by 12. Okay, close parentheses, natural log that. There you go. Okay, we want another close parentheses, close parentheses. And that comes out to be about 12.8 years, plugging into the calculator correctly. 12.8 years. Okay. Okay, last couple of examples here. What is the simple interest rate? So here we're looking for the interest rate on an investment. Okay, well, what's simple interest? Simple interest, that was A equals P times 1 plus R T, right? That's my simple interest formula. Okay, so what was the simple interest rate on $1,700 investment paying, this is an interest in 19 years. Okay, so well, what's the principal here? The principal is P. What's the interest? It's PRT. This is the principal, and this is the interest, right? So we don't really care about the principal. We care about the fact that we have the interest, right? They tell us what the interest is, and they tell us what the time is. Well, we also know what the principal was. The principal was 1,700, so we do care about the principal. So the interest is equal to the principal times the rate times the time. Okay. So the interest is going to be 161602. The principal is 1,700. The rate we don't know yet, but the time is 19.4 years. So I'm going to divide this by 1,700. 1,700. Okay, and I will get 19.4 R is equal to, whoa, what the heck? Okay, 19.4 R is equal to 1616.02 over 1700. Okay. I could divide that whole thing by 19.4, and that'll give me the rate. Okay, so here's how I do this one. I do it in stages. I'm going to go 16.02 divided by 1700, and I'm going to hit equals. Boom, gives me that. Okay, and then I'm going to divide this by 19.4. And it says, oh, look, R is equal to 0.049, which is 4.9% interest. I'll call that the APR, annual percentage rate, for the simple interest there. Okay, suppose that you pay back $385 on a $375 loan. What was your simple annual interest rate? Okay, you had the loan for 45 days. So this is like one of those payday loans, I guess, right? Okay, so you went out and got a payday loan, and you said, hey, you know what? I'm getting paid in 45 days. Can you loan me $375, and I'll promise to pay you back an extra $10. Okay. So what is the simple annual interest rate here? Okay, 45-day loan. Okay, so interest is equal to principal times rate times time, right? So what's the interest? What's the interest on this loan? Well, the interest is $10 because it's just the 385 minus the 375, right? That's the interest. Okay, is equal to $10. Okay, so what is the interest equal to? Well, it's equal to the principal, that's 375, times the rate, times the time. Well, what's the time in this case? Well, we want an annual interest rate, so the time is 45 out of 365. Okay, so I just have to solve for R using some algebra. Okay, the first thing I'm going to do is probably multiply both sides by 365 over 45, the reciprocal. That's going to give me 3650 over 45 is equal to 375 R. Does this go in evenly? 3650 divided by 45? Nope, it doesn't. That's fine. I'm just going to leave it like that. Then I'm going to divide by 375. And once again, I'm going to get R. Okay, 375. Let's move this over here. We get 3650 divided by 45. Boom. Divided by, hit equals, divided by 375. 375. Okay, and I get 0.216. That's 21.6% interest. It's like a credit card. Okay, 21.6% interest rate on that simple interest loan. Okay, and that's it. That's chapter 5 and chapter 7. On Monday we're going to review, and then Wednesday you're going to take the exam. Okay, so go through the review before you show up. I do not have time to go through all 39 questions, so pick out the ones that you want me to go over. Okay, and we'll spend an hour and a half reviewing on Monday. Okay, you've got your project.
Okay.
You've got your project to start. You've got your homework, regular homework that's due Sunday night. You have the review to start working on. That's due on exam day. And did I already say the project? You have your project. So you got a lot going on in the next 10 days in this class, okay? Make sure that you're studying for the exam. The exams are worth you know, I think it's like 85% of your grade in here, okay? And so the exams are just going to kill you if you can't, you know, half of it comes from showing me your work. You know, half the points are basically a gimme. If you can show me your work, the project is worth half an exam grade. So if you just answer all 12 questions correctly, that's an easy 100 points too. You know, like there you go. That makes sense. Okay, see y'all on Monday. If you have any questions, let me know. I'm always available through email, on Canvas, or through my school email address.